Hi everyone! In this lesson, we will talk about how to choose data structures for representing graphs. As I'm sure you'll recall, computer memory is organized into locations in which data are stored. Accessing data therefore requires us to know at which location or address they've been stored.
In the same way that it's harder to find a house by its description rather than by its address, or a library book by its title rather than by its call number, it's easier to find data when you know the specific address.
Let's imagine that we want to store the adjacency matrix of a graph. One way to store data in memory is to use an array. Arrays are adjacent data structures that are used to represent sequences of data where each piece of data uses the same size in memory. So if you know the address of the first piece of data, the address of any other piece of data can easily be computed. For example, if the first element address is 45, and if each piece of data is stored using one address, then the fourth element address is 48. So this means that you can rapidly access the nth piece of data of an array. On the other hand, accessing the nth non-zero element can be time-consuming, because all cells need to be checked one by one to see whether or not they contain a zero. In terms of graph adjacency matrices, arrays are efficient to check if two vertices are connected by an edge. On the other hand, they are not that efficient if you want to retrieve all the neighbors of a given vertex, because you need to test each vertex one by one. Another common data structure is a list. Lists are not adjacent in memory, and to find a piece of data, you need to find all the previous ones first. The principle of lists is that each address not only contains data, but also the address of the next piece of data to look for. So, if you want to access the third piece of data in a list, you first must access the first, look at the address of the second, then look at the second to find the address of the third. Accessing the nth piece of data in a list can be time-consuming. However, it is possible to overcome the time-consuming process of accessing the nth piece of data by only storing pieces of data of interest, which considerably reduces memory usage compared to an array. In terms of graphs, lists can be used to store only information about the neighbors of vertices, for example, since non-neighbors are often irrelevant. If each vertex has only a few neighbors, representing only neighbors with lists can significantly save memory. On the other hand, checking if two vertices are connected by an edge may require you to search the full list of neighbors. A final example of data structures is dictionaries. Dictionaries are elaborate structures that aim to combine the advantages of both arrays and lists, in particular, fast access and efficient memory usage, respectively. Dictionaries make use of hash functions, which are basically mechanisms to transform contents in addresses. This is the optimal choice for prototyping because it allows programmers to benefit from speed of access and low memory usage at the same time. As a rule of thumb, dictionaries should always be used if you don't know exactly what you're doing. Thanks for your attention. That's it for memory structures, and I will see you again very soon to talk about good programming practices. Bye!